All right, we are live here at the Virtual Design Master headquarters. Welcome everybody to our first challenge defense. This is a very unique opportunity because again, we've got a great field of competitors, and it goes without saying that once again, we've got lots of folks who've brought really cool technical knowledge, excuse me, and some really good background. Oh, excuse me, I'm choking out. Angela, if you could read through our sponsor list and perhaps and help us out here.
Yeah. Just so folks know, it's going to be a tough one today, so Eric's kind of coping. So I'd like to introduce or let people know about our sponsors. We want to thank VM Turbo, James Brown, Brian Sir, Jason Langer, Timothy Patterson, and Stephen and Kuduzo. I always have a hard time with that, for their participation in the competition and their generous gifts for the competitors. We appreciate their involvement very much. So with that, I want to introduce the three judges tonight. We chatted quickly about them on the premiere last week. I want to introduce Renee Van de Bedum, VCDX 133. How you doing, Renee?
Great. Excited to be involved.
Good to have you back. You're a big-time supporter of Virtual Design Master from the early days, and early days isn't too long ago, so we really appreciate your involvement and the mentoring that you provide a lot of these folks during the competition. So thank you very much for your participation.
Yep. Hard to believe you're at season 4.
Yeah, I know. We also have Brian Kirsch. How you doing?
Doing good. Happy to be back.
Good to see you. I know we actually saw you I think last week at .next. It was great to see you. Good to have you back and participating. And this year we have a new judge, Edward Halicki. How are you?
Hello, fine. Thank you for having me.
Good to see you. And most folks know Edward's specialty is security, and I kind of mentioned that in the last in the last episode. I don't know if we were tipping our hat there or anything, but some interesting times ahead, that's for sure, in terms of design challenges. So.
Wow.
Yeah. That's right. There's evil all around.
Great to have you guys part of the program and for your help in the community building. Really appreciate it. So with that, I'd like to welcome a few of our competitors. What I'm going to do is I'll introduce you, and then maybe you can just give us a little bit of background on yourself and let the folks get to know you a little bit. And then what I'll do is I'll kick off the design defense, and the judges will ping you, ask you a few questions about your design, try to get a better understanding of some of your thinking behind some of your choices. And we'll go from there. So I want to welcome Stalin. How are you?
Hello. Hey, how you doing, guys? Can you hear me?
Yep.
Yes, I'm sorry. You got the connection got freezed up a little bit. But yes, my name is Stalin Peña. I basically I work for a gaming company. That's why I apologize if I'm a little bit wearing a hat today. It's because we basically dress down all the time. So if you guys play video games, let me know. I can basically hook you up with some games.
There we go.
If you like 2K games or Rockstar games, please let me know.
Good stuff.
So let me just give you a little bit of my background. Basically, I've been working with VMware products since the GSX days. I hold multiple advanced certifications, both of my BCAPs, and in data center administration and data center design. I also basically hold the BCIX MB. I'm a big fan of basically VCDX133.com. I use that to prepare for my VCIX. So thank you for that. I really appreciate your work. So yeah, I'm as a matter of fact preparing right now as Melissa. Thank you, Melissa, for introducing me to the group. We went to the workshop in New Jersey here together, and that's how I basically found out about the group and basically having the opportunity to practice more of my design. So I'm basically looking forward to submit my BCDS MB design for August 26 as well.
Good, awesome. Okay, so I think you know how it works. What I'm going to do is I'm going to give you 90 seconds so that you can explain your design choices in front of the judges, so they can get an idea of what went into your thinking when you produced your design. So I will cut you off at the 90-second. I'm not trying to be rude. I just want to keep it really tight. So Stalin, your 90 seconds starts now.
All right, here we go. So basically, my company name is Skyfalls. Skyfalls is basically an IT security and infrastructure company that has been hired by our billionaire friend to basically put together the design for a data center on Earth and a data center on the Moon. So what Skyfalls has basically decided to do is to utilize hardware from a company called Cisco Aros, based on the UCS technology. What we are doing is we are going to basically concentrate in creating a management cluster in both data centers that is going to be composed of C-class 520 servers. And also we are going to utilize Blaze servers in order for us to host our compute cluster. So in essence, what we're trying to do is we're trying to separate the management servers from the compute servers in order for us to guarantee and segment the traffic between the virtual machines. So the management cluster will host all the virtual machines that are going to be just for management, and the management of the virtual infrastructure that we are proposing, and the compute cluster will host basically the applications that are required for the project, which are basically the applications that host the Humanity Link software, and at the same time the 20 web servers, the 5 database servers, and the application servers. Something that we are basically taking in consideration as part of the project is we are trying to use a Wi-Fi connection that will be strong enough for us to basically share data between the data center 1 that is located on Earth and data center 2 that is located on the Moon. Something that I forgot to mention is data center number 1 is basically located in the desert of Nevada, in exactly Area 51. The reason for that is we're trying to make sure that in case there is another zombie insurgency, we try to basically prevent them from getting to us very fast.
All right. All right, Stalin, your time's up. Good.
Thank you.
That's out of the way now, so you must feel you can take a breath now, my friend.
Yes, I am.
Yeah, good. So I'll turn it over to. I'll ask two of the judges to comment on your design. Brian, any feedback for Stalin?
Absolutely. So, great design, great paperwork. I've got to ask you, though, you went with the blades.
Yes.
Now, this Humanity Link is pretty critical.
Correct.
So, chassis issue. Everything goes away. What's your thought process here?
Let's say as an example, due to the fact that we don't know what is the type of infrastructure that we're going to have in this situation, we're trying to minimize the footprint inside the data center. That's the reason why we wanted to consolidate the Blaze servers or the servers into a Blade format, so that way we can basically minimize the footprint of the servers inside the data center at the same time. But yes, you mentioned a good suggestion regarding the chassis itself. Let's say as an example, if the UCS chassis goes down, all my blades goes down. In order for us to basically fix the issue, we're going to advise to have a spare chassis, or basically have a secondary chassis per site, in which we can basically host some of the blades for production, like half of the blades for production and half of the blades as well for production in the other chassis. Unfortunately, my design is partial, and I couldn't include that, but yes, that will be my solution to the situation.
Okay, thank you.
Thank you.
Thank you, Stalin. Edward, question for Stalin?
Yes. One of the things is that you mentioned having an AMP type cluster for management, and also having that, but having a separate cluster for data.
Yes.
I find that, I mean, that's fine. I have no problems with that particular aspect of the design. What is missing, however, in my opinion, is the fact that all hypervisor-based clusters, and in specifically UCS-based clusters, have management as part of each cluster. How are you going to address making sure everything is kept separate? That's question number one. The second question is, you just dropped this in the middle of the desert. You didn't tell me how you dropped it, so I'm assuming you did it piece by piece. in crates. How are people going to survive in a desert?
That's a very good question. And first of all, thank you for both of the questions. My answer to question number one regarding the reason why I have a management cluster. Um, the main reason behind that is we're
Actually, the
trying
question
to.
wasn't why you have a management cluster. The question was, do you realize that management spreads throughout both clusters?
Okay.
How do you handle that?
Well, let's say as an example, are you asking regarding am I managing the hardware itself or am I managing the hypervisor itself?
I'll
But
give you an answer. Yes.
oh, all right. So let's say as an example. In order for me to manage the hardware or the components of the UCS infrastructure, in my case, I will basically utilize the UCS Manager application that comes with the hardware itself. In order for me to answer your question regarding how am I going to get the hardware to the desert, the hardware in this case has to be basically transported over airplanes, or it has to be transported over helicopters in order for me to get it to the desert. One of the constraints of the design, as I explained in my design, is that having the population or the employees going to the data center that is located inside the desert might be a complication. So that's something that needs to be taken in consideration.
Okay.
Okay.
Thank you.
Thank you, Edward. Thank you, Stalin. You can now relax. Your review has been completed. Good job.
Thank you, guys. Thank you. I appreciate it.
We're going to go to Paul now. How are you doing, Paul?
I'm doing all right. How is everybody doing today?
Good to have you on the competition. Maybe give the community let the community know a little bit about yourself and what you do.
All right. Well, as he stated, I'm Paul. You can find me on Twitter at ExploreVM, and ExploreVM.com is where I blog occasionally. I'm a data center engineer for a company called Presidio. We focus pretty much everything. My specialty is data center, storage, compute, backup and recovery, and virtualization.
Great, good. Before we jump into your defense, if I could just remind the participants, because we have about 10 participants, if when your defense is over, if you could just drop off so we can bring other folks on. So Stalin, we'll catch you later. You can continue watching at virtualdesignmaster.io/live.
Thank you, guys. Have a good one.
Thank you. Okay, Paul, I gave you a few more seconds there to kind of settle in and get ready. So you have 90 seconds to explain your design choices starting now.
Okay, so Mr. Billionaire is funding the repopulation of Earth. The Earth Repopulation Technology Heroes, or Earth Team for short, has been assigned to this task. First and foremost, addressing the data center location question, we are heading to Chicago, Illinois. The selection of Chicago is based on its proximity to fresh water and food sources, to answer how do we keep people alive, and its infrastructure overall, with pre-existing data centers in the area that we can repurpose for our new Earth, we'll call it. And then, so let's dive into the hardware. Hardware, we're going into a new world. We are repopulating, we're refresh of Earth after the zombies, so I went with something I don't really know much about. I took that dive and I went with Nutanix. Let's go with hyper-converged infrastructure. I know this contest is about getting in and diving in and taking a look, so that's kind of what I did. Given the fact that we've only got 46 VMs, I did it all in one cluster, both Nutanix cluster and VMware cluster. And the hardware selected, we've got ample resources. We've got approximately twice as many resources we need to begin. It's nice having a billionaire behind you with pretty much no budget constraints, at least on this go round. And both the Earth and the Moon data centers are going to be identical. Again, there's no budget constraints. I did that as designed to keep everything identical, so that way when, say, we've got to evacuate the Earth data center for whatever reason, there should be no issues in getting everything up and running in the moon data center. There'll also be replication site to site to keep critical VMs going.
All right, Paul, your time's up. I had to cut in there, so
That goes quick.
it goes quick, my friend. Renee, any questions or comments for Paul's design? And I think you might be on. Yeah, there you go.
Yeah, there we go. So you talked a little bit about the Nutanix cluster that you designed. When you were doing the selection of the hardware appliance, what were some of the design considerations that you needed to address?
What I looked for was I wanted to find a Nutanix node that was dense for space constraints, and obviously it had to meet the RAM and CPU requirements for the number of servers that we had based on what was provided.
So CPU and RAM were two of them. What were some of the other criteria that you needed to consider? Because remember, we're talking about an appliance.
Well, I went with the multiple nodes within the appliance for redundancy, as well as I added on the 10 gig Ethernet cards to go up to the.
Yep. So you had network. What else? What else was there? So what are some of the other hardware components in a Nutanix block that you need to size, because you have to size the cluster. So storage is another one. What else?
Yeah, I was about to say I went with 1.2 terabyte SSDs, which were the largest available for that particular node.
Right. Yep. And what if that cluster was to be a VDI cluster? What could be something else that you would need to consider?
This is where my newness to Nutanix is going to show.
All right. Okay. So what I was thinking of was if you were using virtual GPUs. Yeah.
Oh, okay.
A couple of Nutanix models have got only a few have GPU as a hardware option. Okay. Cool. Thanks.
Thanks, Renee. And I do want to stress with folks, it's the items that the judges press you on, it's really to help kind of get a sense of what you're thinking and maybe expand your thinking for maybe another design challenge down the road. So, I encourage folks to maybe watch the replay and kind of get a sense of where the judges are kind of poking you and getting an idea of what your thinking is. So that's great. Thanks, Renee. Brian, any comments for Paul?
Absolutely.
I saw that smile.
So one of the rubs on hyperconverged infrastructure is running out of one resource, whether it be compute, memory, or in this case, storage. Now, we don't know what Humanity Link needs. If there's Oracle on the back end, it could need, like a couple petabytes. What are your thoughts? Because your Nutanix nodes, you're kind of limited at that 1.2 terabyte per drive times X number of drives. So thought process on, there's no spinning disk, you didn't put any in there, so thoughts?
When it comes to spinning disk, as we all see the price of spinning disk versus SSD is coming down to the point that they're pretty comparable if, and sooner or later it's going to pass. So I went with all flash, knowing that the Humanity Link software needed to just have performance. Performance was called out in the design docs. That's kind of what I focused on with that. As for spacing, again, the initial, without knowing everything behind the Humanity Link software, rough estimates based off of some research of various other softwares, we start with twice capacity of what we need. And then with the hyperconverged, we can just add more nodes to the appliances to add the spaces we need. The current design in the dock calls for 2 appliances at each site. Appliance 1 is full. Appliance 2 has a single node and has space for 3 more. So we can quickly add nodes and then add more appliances to the cluster as needed.
Okay, thank you.
Great, thanks, Paul. Your turn's over, my friend. You can breathe now. So thanks so much. You can drop off. We'll bring on make space for competitors in the second round. So thanks so much.
All right, no problem. Thank you, guys and gal.
Great. Now we'll go to Kalin. Did I say that right?
Kalin.
Kalin.
Close
Great.
enough.
Good stuff. So maybe you can give the community a little bit of background on yourself, and we'll go from there.
Well, my name's Kalin. My Twitter handle is @Kalin. Right now, I'm a system administrator at Grand Canyon University in Phoenix, Arizona. Doing a lot of different things, hanging out with my family, anything I find fun with technology. So.
Great. Good to hear. All right, you have 90 seconds to explain your design choices starting now.
Okay, guys, so my design involved utilizing Docker for the application, CentOS for the bare metal OS, and the Intel NUCs for the hardware. I chose Intel NUCs because the primary hardware was destroyed by an airstrike, and the equipment is what the SpaceX team found at a nearby Fry store. For the OS, I chose CentOS to run on the NUCs and the OS running within the container. I only install the required software to run the Docker applications and then use Docker Swarm for clustering of hosts. I decided to run the automation and the management layer within the Docker containers so that they can more freely move within the environment and not be tied to a host and be for HA to bring up if anything ever failed. I'm utilizing Ansible to do the bare metal installs, to do the updates within the OS, and then any applications you needed to add on the fly. For within the Docker containers, I'm using Docker control plane to be used for the monitoring and the cluster management. In case any of the applications failed, you could bring them up as needed. The applications, I guess, if these were needed, I chose to front the Humanity software. I chose Nginx for the web tier, and then I'm doing also some memcached caching to balance the user load. I chose as a backend database MariaDB with a Galera clusters, so I can utilize multiple masters for replication, and also when we separate between the Earth and the Moon, just so I can get HA in a fully availability. I'm also using Nginx as a load balancer for the control plane. And then to make it easier, each application that I'm deploying, I'm using a separate Docker file that's using all the requirements, so dependencies are met and everything like that. Also,
your time's up. Good job. You ran through it really good. Good job. Edward, any comments or questions?
Yes, a few things. I like the fact that you actually chose to use OpenSCAP as a way of setting up your core OS or CentOS. How are you planning applying that to actually the Docker containers? That's question number one. And question number two, what happens when the Intel NUCs fail? Because they often fail. This is not server class equipment. How are you going to repair them? And how are you going to move on with a business continuity solution?
So for the OpenSCAP thing, what I would utilize is for the internal OS, I would use Ansible in my YAML files. Anything that I needed to implement in that portion, I'd have settings enabled through all that. With the Docker files, I'd also add any options within there. So anytime if I had a machine that failed, I just deploy it there, so it'd always be there with a new machine no matter what. And then also with the NUCs, with the way I designed it, I don't really care if it's a NUC or anything I find. I should be able to install CentOS on any hardware and also deploy Docker, no problems. I'm not limited to a NUC per se. I could utilize anything I wanted.
So are you saying that your design requires me to have the repository on every NUC?
The repository for like SCAP?
For Docker. For the Docker images, the repository. Where's my repository?
The Docker file should be stretched across the cluster.
Okay.
Utilizing Docker Swarm.
All right. Thank you.
Mm-hmm.
Good stuff. Thanks, Edward. Renee, any comments or questions?
Yep. So could you just explain to me how you sized your cluster, the process that you went through to do the calculations?
Well, what I pretty much did is I limited it to what they found at Fry's, whatever was in stock at Fry's or whatever they found there. So since the limit for a NUC was 32 gig, That's my limit on the host.
Right.
My storage was all the Samsung Pro 950, the NVMe, so I always have local storage that was there. And then I guess a design constraint was only one NIC, but I mean I could have utilized the USB one, but I didn't want to have any like kernel panics or anything based on that.
So how did you arrive at the count of 6 nooks per site?
That's all they had in stock. That's how I ever.
So
and I would assume that would be.
So let me ask this question: if they had have had more nooks in stock, what would your cluster design have looked like?
It would have. I guess you could have had some. You could have separated out for management, or you could have. Well, I guess I wouldn't have wanted to do that because I'm clustering, so I can spread it out. So I could have grown as needed, or I could have used any model. It didn't matter. It was just
the reason I ask is the infrastructure that was specified in the challenge. You did not have enough RAM resources to run all of that infrastructure.
Yeah, yeah. I guess I would have needed to find something with a little more power, but I guess at the time, because of their airstrike, they were at a, needed to quickly get something up and running.
Okay. Well, thank you.
Thanks, Renee. Okay, great. That's great, Kalin. Thank you for you can drop off and continue watching, and thanks for sticking in there.
Thanks.
Okay. Vlad, can you hear me?
Valdecir, it's me.
Yes. Hi. How are you? Good to finally see you over the internet.
Yeah. How
versus
are you?
over Twitter. Great to see you. So listen, I know you joined I know you joined a little late, so I'm going to give you a few seconds to introduce yourself and give the community some background info, and then I'll go into the design defense. So if you want to let the community know a little bit about your background, where you're from, etc.
Okay, thank you. Good night, everyone. My name is Valdecir. You guys can call me Val. It's a little more easy to speak. And I'm 30 years old now. I have two sons. I'm a father of two. Sorry for my English. And I work as a sysadmin for a lawyer company here in Brazil. I have a blog in Brazilian Portuguese. It's about virtualization and home labs. You can find me at home lab on Twitter.
Good stuff. So you have 90 seconds to explain your design choices, and if you get close or go over, I'm gonna kind of cut in on you. So just to
Okay.
get you forewarned, but you have 90 seconds to explain your design choices starting now.
Okay. As you guys could read my document, our billionaire friend, and I sorry, speak
No,
to
it's
in
okay.
English.
It's
A little bit
okay.
difficult. Uh, the scientists discovered a new material called hemp-fin, and with that material you can build anything from servers to to space rockets, and you name it. And I create the design to having in mind two similar data centers with the same equipment, running both on Earth and on Moon at Moon. From hardware, I choose something based at Evil Rail, and for software, I didn't all the VMware vCloud software that comes with Evil Rail. Both data centers, even in Moon and on Earth, we're gonna be the same. The biggest constraint is to the communication. Is about the latency between the Moon and the Earth. I didn't take anything to measure to measure about that. The applications, they will be deployed in both data centers the same way. And for future expansions, if you need to grow the environment, you can build another server and deploy even on Moon and in Earth.
Good stuff. You're right under the 90 seconds. Great. Good stuff.
Thank you.
Brian, any comments or questions? I think you're on mute, Brian. I think you're on.
Okay, sorry about that. I love the fact you chose a hyperconverged infrastructure, but you only did one appliance per site. So one failure, your whole site's gone.
No, it's two appliances per site.
Oh, it was? Okay. So
yeah, it's gonna be.
Okay, then I misread your documentation. Okay. With that being said, then you're going to do a failover. You're doing what kind of replication between the two nodes?
The replication is gonna happen between the two nodes and between the Earth and the Moon. So if I lost something, if I lost one node in Moon or in Earth, I'm gonna have the database replicated in all the sites.
Okay.
Across.
And you're doing the VMware stack of software, not OpenStack, nothing.
Yes, a VMware stack because I'm more comfortable with that.
Okay, that's fair. That's fair. I'll give you that. Okay. Thank you.
Thanks,
you.
Brian. Edward, any comments or questions?
Yes, I noted. I actually have two. One is I noticed that you actually have your communication links on the dark side of both planets from each other, and you're saying you're using a dual link satellite. Well, to me, that means one satellite. The dark side of the moon doesn't actually communicate with anything but the other side of the moon because of line of sight. How are you handling this? And how are you handling the delays to a further point away from the Earth?
Yeah, the delay was that was not appointed in the document that you guys provide, but the what I'm gonna have is, as I said before, it's having all the data replicated between the both data centers. So
well, the time dilation or difference between the Earth to the Moon at apogee is about 2.7 seconds. That's a fair amount of delay. And if you put it on the dark side of the Moon, it will be even higher than that.
okay,
Now I
you
have to
got me.
bounce through multiple satellites. I can't just go through one. I actually have to go through the satellites at the Lagrange points of around the Moon, which adds a huge amount of delay. So my databases will get out of sync by seconds, if not tens of seconds. When the database is out of sync that way, how have you considered making sure they're not out of sync?
Yeah, I cannot answer that now.
Okay.
Okay, no problem. Great. Renee, any quick comments or questions?
Yeah. So I noticed from your switch design, you had an interesting switch design. So could you just explain the traffic flows for your east-west traffic?
Okay, I choose to have two top of rack suites connected both in the both nodes of the both Everrail nodes, and then connected to two routers. And I used to I did this design to prevent if I lost one of the switches or one of the routers, the nodes is to able to communicate to the other data center.
Right. So what is the path that your storage traffic follows?
Sorry?
What is the path that your storage traffic follows? Your storage traffic. Yeah.
The storage is it's running inside the node. We don't have. I really didn't get your question. I didn't understand what.
So
he's using.
Sorry.
The storage is built into the appliance, right?
Yeah.
Right. So one of the problems was that your switch design, you did not have an inter-switch link between your two access switches. So your east-west traffic would be traversing the routed network.
Yeah, but can I answer that? But
yeah,
if I have a link between the switches, I could make a I forgot the name in English.
A bond, a lag,
No, not lag. Ah,
VPC, trunked
mm,
links.
I forgot the name. It's gonna create a loop between all
Welcome to
the
STP.
yes, yes,
STP
So,
loop.
so
yes.
that's
That's it.
so that's why we have spanning trees. Spanning tree
A
stops it.
spanning tree. That's it. If I have a link between the both suites, I could create a loop with and
But
spanning tree.
but but that's what spanning tree is for. Spanning tree is to stop that.
Okay.
So you kind of answered your own question. You should use spanning tree and connect the two links together. Yeah.
Okay. Thank you.
Cool. Thank you.
Good, good. All right, Vlad. Thank you so much. You can drop off and continue watching at virtualdesignmaster.io/live. I believe I have that right. Correct,
Okay.
Eric?
Yeah, live.html. That's good. Yeah.
.html.
Okay. Thank
So
you, guys. Bye bye. Good night.
thank you, thank you. Good stuff. And I think I'll pass it over to Eric, or should I? No, I will continue with the. I think we have all the.
We're rolling into Team 2 now, so we can tell you that we're at the sort of the halfway point on a lot of the defenses. Everybody's really nailing it so far. You can see the kind of interesting questions that are going to come up. Team 2 kind of got a bit of an advantage here. They got to see what kind of stuff they can expect. With that, we'll get rolling. So yeah, Angela, if you want to start introducing the Team 2 folks, we've got one more that I've got to bring on, and
Okay.
and we're gonna keep rolling on through.
Okay, great. Thanks, Eric. So great to see everyone. Thanks for joining us. This is pretty exciting. You got to see the first round go through the, not the ringer, but really get pressed on some of their design choices. It's pretty exciting, and like I mentioned earlier, you really got to listen to the judges because they're really here to help you sort of clarify your thinking for future design. So it really listen to what they have to offer, and I also encourage you to maybe watch the replay of the video at some other later point. So with that, I'm going to bring on Lewis. Lewis, how are you? Lewis, you're on. I think you're on mute.
I am. How you guys doing?
Good, good. I think I surprised you by bringing you on first.
Just a bit, yeah.
That's good. So maybe you can just give the community a little bit of background on yourself, and then we'll go into the design defense.
Okay, I am currently a VMware Core SE for the commercial division. I cover quite a bit of the products that VMware currently has. Before this, I was actually a virtualization engineer for a VSPP, or VMware service provider, covering 3 countries, about starting in 6, going to about 8 deployments of vCenter, all spread across from Orlando to Vegas and London and Frankfurt.
Great, good stuff. Before we kick off your 90 seconds, I will mention to you and to other folks that if you begin to go over your 90 seconds, I will cut in on you and sort of cut you off. I don't want to be rude or anything, but I do want to let you know that up front that I will cut in on you. So with that, you have 90 seconds to explain your design choices starting now.
So it's a unique issue since we're going back to Earth, but we're still going to keep some lunar infrastructure. And connectivity, I think, between the two is kind of more important for me at the time, as I was going through and looking for how to make this work. There's a lot of great ways you can go about doing that, but radio communications is usually the slowest. I mean, when you look at your satellite internet service providers, they're not all that great. I concentrated heavily on that aspect for this go around. So I looked at what's called the LLCD, the Lunar Laser Communications Demonstration from NASA. It's a laser-based data transmission where they send multiple beams pointed towards a target. As the beam reaches a target, it obviously gets bigger. Having multiple hit that simultaneously gives you a better kind of coverage in case, say, one area or one of those lasers is covered by moisture or certain atmospheric conditions. I thought it would be a better method for communication because the Earth is already covered with quite a lot of fiber, and we can reuse a lot of that stuff from a lot of the Tier 1 and Tier 2 ISPs, but getting it from here to there is still kind of a major issue, and is getting it as low as possible would probably be the best thing we could do. And so it drops a round trip from anywhere in the world to the moon and back to 2.766 seconds. Beyond that, I was looking at more of a hyper-converged infrastructure just for the kind of automation and scalability, so we could make sure that when we go to deploy something, there's less that has to be involved from an engineer standpoint, a lot more that you can automate through either scripting or certain tools that are already available.
All right, good, Luis. I'll cut you off there. Good explanation. And sorry, I think earlier I may have called you Lewis. Sorry about that.
No worries.
I was just quickly glancing at the name list, so apologies. Edward, any comments or questions?
Well, actually, I have quite a few. But
oh boy,
it's interesting that you're using a experimental technology that requires line of sight.
Yeah.
So if you're currently on the wrong side of the Earth, you get absolutely no communication unless you have some other things moving.
Right. Yeah.
I could not assume that all the fiber links would be there. I've seen too much damage to roads and so forth from just us.
Yeah.
I'm assuming that it's actually going to be worse then because it hasn't been kept up to date or even upkeep. So how are you going to manage rerouting all that fiber if that's the way you want to go, or are you going to use some other mechanism to ensure that communication? But also a 2.67 second delay is pretty impressive. And when you start talking about missing half the time for half the planet, you now have even longer delays. So how are you going to build into your environment handling multiple delays of that nature?
So I think that's mostly going to be on the application side, right? If an application sitting on Earth and there's an application that has to communicate with on the moon, you really have to build out on the application side, making sure that it can handle that delay. Less so trying to rely on your infrastructure. Your infrastructure is always going to be inherently going to be slower. You can't defeat the laws of physics. It's just not that easy. So if an application is coded correctly, it works well, and it maybe either balanced between the two sides, whether it be caching a part of your application that's most used across the board locally, or maybe waiting longer for other things, maybe where you have more infrastructure somewhere else, that allows you to make that traverse across, well, space without having to rely on that being a critical path. Now, as far as, yes, there will be we have to check on what that infrastructure is down below. And there is quite a bit of infrastructure that I would assume to be still good, and we'd have to do those checks. Stuff like deep sea fiber, stuff where you're traversing across the world in long distances. Those are more critical because those systems would actually help us to put multiple sites where we could use these lasers, which are line of sight. The idea was that you'd have 8 locations around the world, and so that I could traverse at least some of that fiber to get to the best known route. And so by building out, because we already know where the moon's going to be in relation to us, we can map that out over a long period of time. So we can program what is the best route at any one time. At the same time, you have 8 locations, and each of them are made up of 3 lasers within a rough so many miles apart. The time difference between each of the lasers would be pretty low to still be useful.
Okay.
But with 8 locations, you could at least make sure that 3 should be within line of sight of the moon at all times, so you still have that kind of like a RAID 5 functionality. If one goes down, I should be okay. I've got 2 others kind of back it up if there's atmospheric conditions that are going to get in the way.
Okay, great. Renee, any comments, questions for Luis?
Yep. So in your design, you spent quite a bit of time talking about the data facility infrastructure. Could you just take me through the process of getting infrastructure up and running on the moon?
Well, that would be the hard part, right? Not much was said about what we have available in manpower, and a lot of the decision will have to come once I have more information to work with. And that really is on me for not asking those questions ahead of time. We're kind of reaching out to get a better understanding. But as the design evolves and as those questions are asked, I'll try to make the best decision I can as to how we can get it there, whether it be through some form of, I mean, let's be honest, if we've gotten to Mars, we have to have some kind of robotic functionality there. We can't have done it, and if we have the ability to make any and all future hardware, there's got to be some kind of automation and robotic functionality to help us along with that process too. We can't do this by expecting human labor to do it all. And so I think we could prove pretty well with that.
So let's look at the data center facility infrastructure. Well, actually, it's more like a server room, I'm guessing. How would you get it there? Would it be in pieces, you build it there, or would you send it as one completely a space V block, let's say? Would you deliver it that way? How would you do it?
So I think doing a teaser where the space V block might be a little too forward thinking. Far too often you're going to notice when you're trying to send something as complicated as this, you're going to have some issues when you're trying to land it. I wouldn't trust that as much as long as I can put it into smaller chunks that can maybe be piecemealed in as easy as possible. Part of my job was I spent a lot of time trying to work with companies to do the integration, and personal experiences, sending a whole rack and making it just plug and play as possible doesn't always work that well. But if I can make if I can make the assembly once it's there as easy as possible, I can then make it easier to deploy. And
that would be via what type of agent? Human-based or robotic?
Well, if I'm going to send hardware anywhere, I'm probably going to want to have somebody there to make sure that it gets there correctly, everything checks out. Humans will probably have to be a big part of that. I mean, we can't go down on Earth. We can't come back to Earth without having somebody go down there and check it. You could send a drone, and that's great. But once the stuff gets there, how are you going to make sure it gets connected without some kind of security?
Okay, cool. Thank you.
Renee, can I ask you one question? This just brought something up that was rather intriguing to me.
Please.
You said with some sort of security. What do you mean by that?
So, you guys didn't say that all of the zombies were gone. You said that it looks like most of the zombies are gone. So, with that being said, I don't trust that statement enough to do it without somebody being there to help secure everything when it gets there, and the people who have to put it together.
Okay, so you're talking physical security against zombies.
Yeah.
Okay. Thank you.
Great, good. Thanks, Luis. You can drop off and continue watching. Thank you so much.
Thank you, guys.
We are going to go to Gareth. Did I say that right?
Yes, you did.
Good. Finally, I said something right. Great. Good to meet you. Maybe give the community a bit of your background and what you do.
So I'm a third-line engineer for a company called Commercial Limited, based in the United Kingdom on the lovely rainy island, as many people call it. Oh, sorry, can you hear me?
Gareth, we can hear you okay, but I think your mic is rubbing against your shirt, so there's a bit of, that's better.
So, in my role, I do pretty much everything from VMware, storage, networking. Dare I say it, some of our clients, if it has a plug on it or a clock on it, I will get a phone call. And I'm a regular local VMUGs, and recently I've started a project which Eric knows about called the Open Home Lab, which we've brewed from there. And just if I'm not doing this, I'm doing that, really.
Great, good stuff. So you have 90 seconds to explain your design choices, starting now.
So I took the rather panicked approach, as I unfortunately didn't get to start my design until Sunday evening, as I was away for the weekend. So I've selected a lot of technology that I've used before in the past. Some of these might raise a few eyebrows, and I've tried getting a bit of the home lab idea in there, because I thought, well, if we can modify hardware, how can we make this enterprise grade? And then I've just really expanded on that. I've made a few things high level because I've made a lot of assumptions that our link is stable, our app doesn't need much, our billionaire friend owns many, many things on this planet, and we can live underground. I took a bit of inspiration from Melissa here, really, thinking if we can go Walking Dead, can we go with certain films like Resident Evil? If zombies can't get out, can they not get in? You know, we don't know if the zombies are still there. I I did realize after my submission I'm going to probably get asked a few of these things, but I did forget a few things about my AV, switch layout, and again, without knowing the app, I didn't include a load balancer because I made a very, very wild assumption that it would have balancing built in.
Good stuff. You're way under the 90 seconds. Good stuff. Brian, any comments or questions for Gareth?
Okay, so 2 things. Number 1, size and weight was a concern, and you went with the big HP rack mounts.
Mm-hmm.
A lot of metal, a lot of empty space, a lot of gas, to get that up to the moon. So I gotta ask, why not hyperconverged? Something a little bit more dense, not as much rack space.
Yeah, I completely get your point on that. Where again we were given, dare I say, the sky's the limit and no real constraints. We don't know what our billionaire friend's going to do. So I thought we'd be able to scale out on any ability this way, and that's why I selected the ways that I did. I selected a compute style and a traditional storage style because we don't know how quickly this is going to grow. And I just felt that was the best way of doing it this way until we start understanding what is going to really get run on this infrastructure.
My apologies, I have a Malamute on the side here. Okay, second question. You patented after the Hive layout of Resident Evil. That didn't go so well for the people that lived there the first time. I'm just going to point that out.
No.
Badly.
Or the second, or the third, or the fourth, yeah.
It just doesn't seem to pan out real well. An observation.
Yeah, I completely agree, but we realised that there was a human intervention there that decided to release the virus within the lab. And then secondly, that they did have a bit of a crazy AI, and I did put that in there as a constraint. I hope we don't build some crazy AI along the way that's going to want to kill us down there.
This is developers, DevOps, they're going to do it. I mean, come on.
True. Let's just hope they don't.
Thank you.
Good, thank you. Yeah, Edward, any comments or questions?
Well, I like the buried approach and where you were burying it and all that, but how long is it going to take to get the Humanity Link software up and running? You're talking about a fairly big effort to put something in the ground.
Yep.
While you're doing that, how are you going to protect whoever is doing that? There's a lot to think about there. And then, once I'm in the ground, now I'm limited to what I can poke out and be safe to do communication back to the moon, to raise and all that.
Yeah, and that's why, as you can probably see from some of my design, I thought, well, we haven't been told any timeline for this project, so I'm assuming that we can send quite a few hefty robots. I'm, again, making an assumption that robotics is advanced. We can go dig a big hole in the ground fairly quickly and rapidly. In regards to communications, that's why you probably see vaguely in my design that we have several breakouts within the satellite towers or laser towers where we could hop between sites and we could quite rapidly get these back up online in the event that we do have people scouring the earth, because as you said, we don't know if the zombies are still out there. I'm hoping that, could we even get some of these radio towers on the back of a rover? With the joys of the Meraki that I've chosen, we could use the cellular links to create a point-to-point connection straight back to our main data center, and if needs be, drive a rover around the planet.
But and then actually, the other one is you said you hope the AI, we don't design an AI like that. What are you building into your infrastructure and/or the applications to prevent the AI from going crazy?
Nothing much yet. I'll be perfectly honest with you. That's something in there. I made the assumption that no one's going to want to suddenly kill humanity again. I haven't quite put any constraints in there or any ways of, shall we say, make sure our code doesn't get tampered with.
Good. Okay, Gareth, thank you so much. You can drop off and continue watching. virtualdesignmaster.io/live.html. Thank you so much. So we're going to go to Harsh. How are you? Good. I think you're on mute.
Yeah, hi.
How are you? Good to see you.
Yeah, I'm fine. I'm also glad I'm back.
because
season
we
4.
can say welcome back. Yeah, we have Harsh, of course, was a season 3 competitor, and you did a great job last year. So welcome back again to the fold.
Yeah.
Thank you.
Maybe just give the community a 30 seconds on some of your background so they get reacquainted with you, and then we'll go right into the design, the defense.
So hi all, I'm Harsh. I work for IBM now. In season 3, I was working for HCL, so made a switch, and it's nice to be back on the season 4 again. And I like season 3, and I got good mentorship from a Virtual Design Master. I like to follow along with season 4.
Great, excellent. So you know how it goes. I think last year we gave you maybe a minute, I think it was. This year we've turned it up to 90 seconds. So you have 90 seconds to explain your design choices starting now.
Sure. So HCI is choice of hardware, and VMware SDTC 6.2 is choice of software for this design. And as per the constraint, like we have to build a data center in Earth and a second site on the moon. So my choice for Earth is North Virginia, because AW has its own region there, and I think they have done all the geographical checks about North Virginia, so it is a good place to start with a data center. And I'm using HCI from Supermicro. It is a Factoin 4U unit with 4 nodes, and I've taken care of the compute. Like it has got 4 TB of RAM and around 38 terabytes of vSAN storage. And I'm using all sort of vSAN, NSX, and SRM for designing this data center, primary and secondary. So we are using NSX as 6.2 with a multi-vCenter feature, which will use both the data center, and will be deploying a primary NSX manager on Earth and secondary on the moon, and will use SRM to do the replication of Humanity Link software, which is a paramount of importance. And rest of the stuff, like will use, as you know, HCI has a chassis level issue. So I know like there is just 0.01% chances of chassis failure. So I think we can consider that. That's all.
Great, excellent, perfect. Renee, any comments or questions for Harsh?
Yep. So Harsh, I noticed that you selected all-flash vSAN for your storage solution.
Yeah.
Can you just tell me what you consider to be the biggest constraint for vSAN write performance in your design?
Yes, so biggest constraint would be because we need to make a separation on the physical network side, because vSAN uses multicast. So we need to just make a separation from other networks so that vSAN can use this multicast configuration for vSAN replication across the node. So that is one consideration for vSAN.
Yep. What are some of the other design considerations that you have for vSAN design?
Okay. So another thing that I've used is NVMe SSDs, PCI based, just to keep low on the moving parts and better durability. And another thing that I've used is FTT1, so that we'll have a replica of objects which are stored locally available.
What about the active working set of each of the virtual machines running on nodes in your cluster? How did you calculate that?
So I've just calculated it as based on FTT, and another thing, I just keep forgetting that. So
okay.
Yeah.
That's cool.
Thank you.
Great.
Okay, thanks.
Thanks, Renee. Brian, any quick questions, comments?
Just a quick thought. One of the challenges with hyperconverged is it's a little bit harder to do dedicated management clusters. You know, you're running NSX, you're running SRM, but your management VMs are going to live in the same boxes as your production. It's a little risky.
Yes, that's a risky environment, I can say. per se, because we are using vSAN, so we can't make a separate cluster, because in that case we need to keep separate vSAN data stores. So that's the reason I've didn't created a separate management cluster and kept the management cluster on the same where our production cluster, and there is only separation of the folders. So the thing that I've implemented here considered in the design is keeping components as a redundant. Like we have a redundant PSC, platform services controller. We have another secondary NSX component, and we have another vCenter server which is there on the moon side. So if there is any issue or any thing happens, like if our management component gets failed, so we'll do the migration from primary site to secondary site. Or we can just vMotion stuff, because it is extended vCenter server. So we can just migrate some of the stuff to moon.
Okay, thank you.
Okay, great. Thanks, Harsh. You can drop off as well. Thank you so much. Good to see you again, and good luck this season.
Thank you.
Okay, great. We have now. Is it Katarina?
Yes.
Hi. Welcome.
Katarina.
Great to have you on. I'll give you 30 seconds. Maybe you can just share with the community a bit of your background, and then we'll get right into it.
Okay, I'll keep it quick. So my name is Katarina. I'm based in Bratislava, Slovakia, and I work primarily as a VMware admin. So this is the reason why I joined the VDM challenge, to get more into the design side and practice a bit, I guess, and have some fun.
Good, great. We're excited to have you. So I will give you, like I mentioned to the others, I will give you 90 seconds to explain your design choices. I will cut in if you go over, so I don't want to seem rude or anything, but you have 90 seconds to explain your design choices starting now.
Okay. So what I have done here is that I have created basically two active sites on the Earth and on the Moon, as was requested. To separate the workloads over the two locations, because I was working with the assumption that there are still some people living on the Moon. So I wanted to ensure that they will still have some resources available locally on the Moon. In order to separate the workloads, I have basically created the DRS rules to keep them separate and mapped to the locations where they should be running. I was using vSAN stretch cluster to provide the storage. The reason for that was that I wanted to avoid going for physical storage box, which could fail, so it would make sense to have two per location, which seemed like a bit of an overkill in my consideration. Yeah, that's about it.
That's great. Perfect. Thank you so much. Renee, any comments or questions for Katarina?
Yep. So I noticed that you've got NSX of vSphere in your design. Could you just tell me some of the prerequisites that you need to use NSX?
The prerequisites. So basically what I have deployed was the NSX manager and 3 controllers to have a redundancy, to basically make sure that if one of them fails, we still have redundancy. The reason why I have used it was that I wanted to have some kind of logical option to also further create firewall rules and separate the networks, because with VLANs I basically kept them all together.
So what are some of the prerequisites at the physical network layer? So like MTU sizes.
Oh yeah, I forgot to include that I had to increase the MTU sizes.
To what? Yeah. What's the magic number?
To 1,600.
Yep, very good.
Yeah.
And what are some of the network requirements for the management and control plane of NSX?
Yeah, I think as you can see here, this is not really the strongest part of my design.
Okay.
I wanted to basically include something that I don't necessarily work with, so
Right.
I'm afraid I'm not
Okay,
able
no
to
problem.
answer.
And one last question: what were some of the risks that you introduced into your design by having a stretched vSAN cluster between the two sites?
The risks. Basically, the reason why I did this was actually to eliminate the risk that I could think of,
Right.
and also which
But
would be a physical
but
touch failure.
did you maybe introduce another risk by doing it that way? Is there anything you can think of?
Um, I have tried to limit those, and I'm not quite sure at the moment.
So as Edward mentioned earlier, the latency is 2.7 seconds
Oh, yeah.
between the
So
moon and the
basically,
Earth.
yeah, basically what I have included in my design was exactly the reason for this. I started working on the design using the 2.6 latency. However, with this, I was not able to implement any kind of solution.
Right.
So actually, what I
But
have added to my assumption was that the latency has been dropped by the humanity development and technology advancement
right.
to 4.9 milliseconds.
So for a vSAN cluster, what do you think is an acceptable latency for running a metro cluster? Just off the
That
top
was
of
the
your head.
5 milliseconds. That's why it was very convenient that they dropped it to 4.9.
Okay. All right. Great. Thank you.
Thanks.
Thanks, Renee. And we always tell competitors, Virtual Design Master is about trying new things, things you may not be exposed to in your day-to-day work. So it's great that that you're sort of, let's say, experimenting with these different solutions in your design docs, and with the judges kind of shaping a little bit of your thinking going forward. So that's excellent. That's in the long run that's really going to help. So that's really good. Real quick, Brian, any questions or comments?
One question. The admission control you had on the cluster, 50% reserved. That's a pretty high number. And admission control is kind of a double-edged sword. A lot of people look at it as, I'm not going to use that because I want to run. Even if I run slow, I still want to run.
Mm-hmm.
But turning it on kind of negates some of that. So your thoughts on that?
Yeah, okay, so I went with 50% because as I implemented vSAN, I had basically 3 full domains. So it was the side on the Earth, the side on the Moon, and then the witness. What I wanted to achieve here with 50% resource reservation was that in case one of the sides would fail, I would still have enough resources to run all of the workloads on the other location. So that was my justification for 50%.
Okay, thank you.
Okay, great. Katarina, if you could just stay on, you don't need to drop off because you were the final contestant. I think now I can pass it over to Eric, and we can sort of find out where we are in terms of participants.
Okay. Hopefully I don't choke to death like I did at the start there. So, well, everyone has done amazing work. We can say that we've started off with an incredible set of requirements that were very open-ended, which make it especially challenging to be able to work within a very open-ended set of constraints and requirements. Now, Luis brought up an interesting one. He talked about asking questions. Again, a reminder to everybody who's in here, don't be afraid to ask questions if you're not sure where we should go with particular design decisions. We do have an open forum, and that's not just here, but anywhere else in our community. It's very important. Again, because we had such a large field of competitors, you may notice that there's actually a few folks that didn't arrive today. And we do have to announce that unfortunately we did have 4 competitors who had to bow out prior to their first defense. And this happens for a variety of reasons. Workload is challenging. So with that, I do want to send a shout out to Sean Bravener, to Antic Meropa, Thomas Casa, and also to another of our season 3 alumni, Lubomir Zvolensky. Unfortunately, Lubo wasn't able to continue on with us. He had to pull out because of time commitments. So, again, it's a very interesting challenge with fighting time interesting requirements. But again, the questions that you've heard, it's not about right and wrong. It's about justifying your design decisions. And with that, so we will say that we do have to send someone home. You know, despite having 4 people voluntarily to take themselves out, we unfortunately do have to send another one. And with that, I do have to deliver the unfortunate news. Again, not because of bad designs, but simply just because we do have to narrow the field. And with that, unfortunately, we're going to have to bid goodbye to Luis. Luis had a great defense, but unfortunately, looking at the design document, didn't quite have what we were looking for. Again, judges had great comments about the designs, and we had a great defense. But that sort of shows it's a combination of the two things together. And there's all winners here, of course, because that means that we actually have 9 people that are moving forward into our next challenge. And Katarina, you've actually been held on for a special reason. You've actually won our first spot prize of the event, which is our Judges' Choice Award. We actually had you appear as a top pick from all 3 of our judges this year. So with your first design, you've won we'll call it the James Brown Judge's Choice. James has donated a $150 Amazon gift card, and so we'll connect you up with James to make sure you get that prize. So thank you again to James Brown, and thank you, Katarina, for doing a great job with your first design and defense, and we look forward to seeing much more from you going forward.
Thank you very much.
Now, to speak of going forward, of course, this is a 4-challenge event, and with that, of course, we want to bring back Melissa to talk about our next challenge.
You know, I found it interesting that almost all our competitors were assuming that there were no bad guys on Earth and everybody wanted humanity to be happy. So that actually played really nicely into our second challenge. I will say that I had some help from one of our judges, Edward, so I think everybody who complained the first challenge was too easy. I'm not sure this is necessarily harder, but it's probably different than what you were expecting. So we've been talking about how fantastic humanity has been over the last few years and how everybody has worked together to save humanity. But what if that's the view through rose-colored glasses? We think we know what we've been dealing with, but what if we really don't? There's one person on Earth who has survived the apocalypse deep in the bowels of the supernaps, and they've managed to bring up satellite capabilities. One of our brand new data centers, the closest drop-and-go data center for Earth, has been taken over. While it has not disappeared from any monitoring, it is no longer in anyone's direct control. In addition, the black market for goods and services is accelerating, using your own network against you. All you know at the time of discovery is that a shipping manifest you created has been changed to include some interesting components, and the shipment has been rerouted to go someplace else. However, you notice this after the shipment has left, and there's no time to change everything. The challenge comes in 4 parts. You need to, A, find the extent of the changes anywhere in the system. What were the prerequisites to make this happen? B, you need to be notified of other changes, not just to files, but to attacks. What is the step of an attack? How fast can you detect an attack and changes? C, prevent the changes. Can you prevent the attack or just detect the attack? If only detection, how fast can you make this happen? And finally, determine the root cause of the attack. Can we find the culprit? Is there any forensics data? Where did the bad actor leave his or her fingerprints? Is it the black market, or is it something we don't even know about yet? So this is really, since we have one of our wonderful judges has a real security mindset here, this is kind of a different aspect to the Virtual Design Master Challenge we haven't necessarily had in prior seasons.
And Edward, maybe you want to give a quick comment on, in sort of give an elevator pitch on what kind of stuff you may want to see in this result.
Well, one thing you need to realize is that as of today on Earth, just like really just today within the news, you see breach after breach after breach. The other thing is that they're not always insiders. So you got to think about that. The other thing is the average time to breach detection is greater than 200 days today on average. That is way too high. We all know that from a security perspective. We're trying to reduce it. There's a ton of companies out there and technologies to help reduce that. So you need to get down to a reasonable amount of time. Also, you notice a change in the shipping manifest. There was a book called The Cuckoo's Egg where a guy noticed a change in an accounting program from 53 cents, and that led to one of the biggest hacking ring disclosures in the captures in the world at the time. So small things can lead to bigger things. I want to know how you get from A to B. I want to know how you get from the small thing to figuring out what the rest of it is, and how you're going to defend everything. That's the key, is defense.
Excellent. Well, again, thank you, Edward. Thank you to everybody. Thank you to all of our competitors for we've come well through Challenge 1, and we're heading right into Challenge 2. You'll get an email shortly with all of the design specifics and the wording on the challenge. And, of course, congratulations again to Katarina, and thank you, James Brown, for our $150 first spot prize. Thank you to VM Turbo for providing our grand sponsor prize for the grand finale, and of course for everybody else, if you want to visit the blog, go to virtualdesignmaster.io, and there's a blog link right there. Of course, you can come back every week and watch us live. Our schedule is posted on the site as well. If you're looking to contribute, if you want to add another spot prize, if you want to help to urge things along, please drop us an email. You can send one directly to me, and my email is right on the site, or just send it to eric@discoposse.com. And with that, we're going to close out. We're long on the first one, but we'll have a little bit more time with our judges as we head into further competitions, because the challenge is going to thin the herd a little bit, and we're going to get a lot deeper with how we get into these design decisions. So thank you, everybody, and good luck with challenge number 2.
One more thing before you guys all go off is that if you guys want to ask me questions, I'm at TexieWill on Twitter. I'll be glad to answer anything you guys have.
And there you go. That is community right there. Thanks again.